Greetings and welcome to another ramble with me. We are looking at question 9a of IEB's November 2022 paper 1. In the diagram below, Wx is equal to negative x plus 6 and Tx is equal to x minus 4 are the axes of symmetry for the given graph H, which looks like a hyperbola. E, the point E with coordinates 9, 2 lies on H. ABCD is a rectangle with AD on the x-axis. Okay. And A is seemingly the x-intercept of our hyperbola. C is a point on the hyperbola and one of its axes of symmetry. Right, cool. So first question, okay, and then we get the confirmation that H is in fact a hyperbola. If h of x is equal to a over x minus p plus q, find the values of a, p, and q. Okay, there's definitely a lot going on, okay, but I think the hint is in the axes of symmetry, maybe? Just looking at those equations, and well, also the very interesting thing being that the axes of symmetry intersect where the where the love lasts forever, where the asymptotes intersect. Gosh, that took so much out of me. Right, so that is good to know, because if we can find that point of intersection, then we have found the equations of the asymptotes, and we have found by how much has this hyperbola shifted from its original position, original in air quotes as usual. Alright, so relative to the most basic hyperbola, y is equal to 1 over x, how much has this hyperbola h shifted? Right, so we are going to find the point of intersection of the asymptotes. This pen is too thin, man. I don't have to say it in words. I can do it in symbols. Okay, you can just double check by putting it into the other equation. Okay, so we have successfully found the point of intersection. We have found that this point, okay, let's bring back the skinny pen. This point is 5, 1, right? So therefore, the asymptotes of H are y is equal to 1 and x is equal to 5, right? And that also tells us p and q, right? So that tells us that h of x is equal to a over, so the hyperbola has moved to the right by 5 units, okay, and the thingy wingy, it's moved up by 1 unit, right? Because ordinarily this asymptote would have been here on the x-axis and this one would have been over there at the y-axis. Right, okay, so so far we have 3 pieces of the puzzle sorted out. For the last piece, we're going to use this point that we've been given. So we know that when h is equal to 9, the output of the function is 2. So a over 9 minus 5 plus 1 is equal to 2. A over 4 is equal to 2 minus 1, which is 1. And so a must be 4. Okay, so all in all, we now know that a is 4, p, x minus p, and we found that, okay, at the bottom we have x minus 5, so whoa, the p is equal to 5, and then the q is equal to 1. I think we have plus q up there, and in our equation it's plus 1. So that's that on that. Okay, now for the next question. Determine the area of rectangle ABCD. So in order to do that, we need to find the coordinates of A and the coordinates of C, because once we have the coordinates of C, then we know the x coordinate of D. And the x coordinate of A will be the same as B's one, and the y coordinate of C will be the y coordinate of B. So if we can find these 2 points, then all is well. So we're going to find in another color. We are looking for the x-intercept, so we're looking for where h of x is equal to 0. So promptly forgot all the numbers. 4, 5, and 1. So 4 over x minus 5 plus 1 needs to give me 0. And of course, x can't be equal to 0 to 5, sorry. So 4 over x minus 5 is equal to, not 1, but rather negative 1. And the only way that that can be true is if this number over here is negative 4. So x minus 5 needs to be equal to negative 4. So that is x is equal to negative 4 plus 5, which is positive 1. Right? So that is, okay, so that gives us a. So a has the coordinates 1 and 0. Right, and then to find the coordinates of C, we are looking for the intersection between this guy and this line, T. And there are going to be 2 of them, so we are specifically looking for the one that comes later on the x-axis. So, right, to find C, we are looking for the intersection between H and T. So H is 4 over x minus 5 plus 1, and T is x minus 4. So x can't be equal to 5 once again. So for this one, okay, let's start by doing this. Get the 1 to the other side. That's x minus 5. Okay, so 4 over x minus 5 needs to be equal to x minus 5. So this is almost, it feels like something I can do by trial and error. So 4 divided by some number needs to be equal to that same number. So either x minus 5 is 2, because 4 over 2 is 2, or x minus 5 is minus 2, because 4 divided by minus 2 is minus 2. But anyway, let us do the more comprehensive way, because trial and error doesn't really prove that those are the only solutions to the equation. Right, so 4 is equal to x squared minus 5x minus 5x minus 5 times minus 5. Oh, also, so wait, so when I said this, okay, I just want to finish that train of thought. So that would mean x minus 5 is either equal to 2 or it's equal to minus 2. And that would mean x is either equal to 7 or x is equal to minus 2 plus 5, which is 3. Anyway, just wanted to complete that train of thought. And I suspect I might have said that x is equal to 2 or x is equal to minus 2, which is wrong. Right, anyway, so back to this train of thought. X minus 7 times x minus 3, and there we have our, right, so either x is then 7 or x is 3, as our trial and error demonstrated to an extent. Right. Okay. But we are interested in specifically, so this would be the one with coordinate 3, and this would be the one with coordinate, well, x coordinate 7. So therefore x coordinate of c is equal to 7. And then to find the y coordinate, we can use either equation. In fact, t is easier. Right, so t of 7, what is t of x? T of x is x minus 4, is 7 minus 4, which is 3. So therefore, the coordinates of c are 7 and 3. Of course, just double check, putting it into h. So h of 7, the a is what? Okay, let's just duplicate this. Whoa. Okay, so now our x is 7. So that will be 4 over 2 plus 1, which is 2 plus 1, which is 3. Right. Awesome. So we now have the coordinates of c. Yeah, I'm going to need to get this diagram again, because scrolling up and down is not open. Okay, so what do we know at this point? We now know the coordinates of c are 7 and 3, and we know the coordinates of a are 1 and 0. Okay, so therefore the coordinates of d are going to be 7, 0, because it's straight down from c, because right angles everywhere, right? And the coordinates of b will be, we don't even need the coordinates of b, honestly. Right, all we need is the length and the breadth. So AD is equal to 7 minus 1 units, which is 6 units long. And CD is going to be 3 minus 0, which is 3 units long. And so all in all, area of rectangle ABCD will be equal to 6 times 3, which is 18 square units. Right, let's see what the memo believes to be true. So for the first question, we did indeed have the same approach, which is awesome, and we arrived at the same answers, which is also awesome. Then for the second part of the question, we found the coordinates of A, which is great, and then the coordinates of C, they found to be 7, 3, which is also great, and then the area of the rectangle is indeed 18 square units. Awesome stuff. Right, and that ends that ramble. Catch you another time for another chat.